the terrain. You're never going to be able to do that.
I mean, think that wouldn't
not quite the same thing, but sure.
Yeah, I don't. The reason why they wouldn't be the same thing is, I mean, we would know how, like, for instance, if you were going to measure the coast of the UK to find out how the UK exactly looks here and there, your whatever method they use to measure, whatever scale, whatever measurement they use, could be applied elsewhere, right? The only problem with it is just that different countries, like in reality, is that different countries sometimes use different sorts of methods, and so sometimes if you were going to use one method another country uses, one coastline might seem a bit longer, one might seem a bit smaller. But either way, we know the rough dimensions of all countries on their coastlines at least, and certainly on their borders, right? Because nobody pays taxes twice, right? The two different countries, that is. So that wouldn't exactly create a problem for understanding the configuration of land masses.
It would for mapping. Well, it would for, because that's what he said, mapping the edges of continents. So what is that? That's coastline, right?
Specific problem is that the lengths of the coastline is dependent on the unit of measure that you're measuring it with, but the area is not. The area remains the same, so it doesn't matter.
The area can't remain the same, obviously.
Well, that's what the map is. I don't know what to tell you.
Well, I mean, if the coastline extends in distance, then obviously the freaking area has to extend in distance. Because
it's counterintuitive.
It's the perimeter, right?
You would think, but it's not true. You can have infinite perimeter with finite area.
Okay, sure, dude. How would you even do that equation?
It's
how are you going to calculate the area in the first place?
The topic that you need to read into.
Well, how are you going to calculate the area? That's what I'm asking you.
I don't know. So this is where I'm out of my own depth. You know,
okay.
I just know that I've watched videos about this very topic.
We don't need to worry about it.
I'll tell you how to solve this. Hold on.
In mathematics,
can solve this. Can solve this. It's so freaking easy. Here's how you solve it. The perimeter of any area is 1. You can then subdivide 1 with an infinite amount of subdivisions. It doesn't change the fact that the perimeter is still the same actual distance, 1.
Yes, and then you multiply 1 times 1, and then the area is 1, and everything is 1. We are all 1. We are the monad.
Yeah, I think Indio, your final proposition, it's certainly a good challenge, and I have been having fun trying to figure something out. The one I gave you has been, I mean, the actual argument was made quite quickly, but then when I spoke to Heretic,
I realized it's flawed, dude.
Yeah, well, when I spoke
to dude.
When I spoke to Heretic, I'm not going to get into an argument about the thing because we already did earlier. But I spoke to Heretic about it, and obviously he introduced the idea of some sort of, it's kind of a vague objection with alternative possibilities, and so I had to start doing truth tracking to figure out what do you guys claim that has to imply some scope of what kind of Earth we're talking about, or possible Earths. But I don't think it's possible though to actually do it in 2 premises. I think that's a big ask. It's like, I don't even think the Black Swan. I don't think the Black Swan does either.
What are you talking about, dude? You trying to commit the fallacy of 4 points?
No.
Oh, you didn't know that one?
No, I'm not.
I think you do it in 2 premises, right? But you'd have to so to prove the final 2 premises, you would probably need a series of propositions to even get to that, right?
Yeah, exactly. That's what I'm saying. I think just having 2 premises alone without, having. I mean, synthetic claims are always going to have that sort of nature, where you're going to have a lot of evidence and reasoning for a lot of support for each premise, right? It's a lot. So.
Okay, so let me tell you what the problem is. The problem with the whole thing, why it can never be done. I'm going to tell you. I'm going to give you the cheat code to stop trying. Because it's an inference. Because looking at the sun and drawing a conclusion about something else that's not the sun is always going to be an inference. They're inferentially connected. They're not intrinsically connected. Extrinsic, so you can never actually make a deductive syllogism.
No, it's more useful the other way, where you have a model that would predict an observation, and then
utility is great, dude. I'm not against utility. Believe reality is whatever you want if it's useful. I don't care.
Yeah, I'd agree that if I was going to, so the point of my argument, without all of the other stuff, just the argument alone, was designed to force the person I'm talking to present the debunk, right? Because that's at least how I understand where the burden of proof changes in a debate, right? Obviously, some people disagree, but that's how I understand it. If you present something, you give support for it, then it's the person who's objecting's turn to then, support their objection. But the reason why I did it that way was because I thought that it would be the case that someone would do that. Then I realized that isn't the case, right? Obviously, no one's going to do that. So the next, when I started to do the warrant of the argument, it was to then say, well, look, if you're not going to tell me what are the what is the available possibilities, then I will do it for you, right, based on things that you've said before. And so in that case, these can be falsified and can be done deductively.
And that's kind of frustrating to me. If the flat Earth is in a position where they're saying we won't make claims that are falsifiable, then what's the point of even believing in a flat Earth?
Believing?
I mean, but if it's not falsifiable, you're basically admitting that it's just not, reality doesn't matter to you.
It's the inconceivable flat Earth.
But the observation wouldn't have falsified a globe either. But you don't have a problem with that. It would only have falsified the heliocentric model. That's all it could ever do. It could have only falsified the heliocentric model. Because whatever the sun does, ostensibly, is a heliocentric model prediction that's independent of a globe or a flat Earth or any other thing. Now you can say flat Earth doesn't work within the heliocentric model. Fine. You just come up with some other fucking stupid model.
So, I want to know, why would it bother anyone that we don't want to make claims that we can't back up? It's so weird to me. It's bizarre that the frustration comes from the opposing side because we don't make claims that we cannot back up.
It didn't used to be that way. The thing that initially drew me into flat Earth, the one that, like, I saw some videos initially. It's like, wait a second, I don't have the answer to these things. Well, this is interesting. They're making claims about provable claims. The most famous video at the time was 100 proofs of the flat Earth or whatever, right? By the Eric Dubé, right? That was the line of thinking of most flat earthers, as far as I could tell from back then, is everybody had a pursuit of truth. And then somewhere along the line, people stopped saying that and say, hey, actually, we don't support a model. We don't care to make claims. We just observe the thing is flat and we're cool with just leaving it there. And that's weird to me because that's not what was interesting to me. I guess it's fine to other people and that's whatever, but
that's complete mischaracterization.
I'm just giving you my anecdotal personal perspective.
Okay, well, my perspective is that your way of thinking is weird. So we could go back and forth like, no, not me, you, or you, not you,
that's
me.
Because, so this is what you don't understand, Dan. We think it's over. We thought it was over 2 years ago.
Okay.
Like, there's nothing left to investigate. We've done the tests. We've measured the surface of the Earth. Nothing the sky can do or any freaking concepts you guys can come up with in the sky could ever falsify it. It's not even possible. Yeah, but as a logic, all you could ever do is go out and say, hey, we actually went out and we measured curvature of the surface of the Earth. Your measurement's supposed to be wrong, or we'll do a third measurement and, split the difference or something.
Like, but to your point about it not falsifying the globe, you're right. It would disprove our heliocentric model. But I would find that just as interesting. You're right, but that's awesome. You guys should be just as excited about learning more about the flat Earth model. It's like, okay, accept that it's flat. You believe it's flat, but now what's next? Why isn't that next question interesting to you?
Why isn't what he just said interesting to you?
So it'll always, anything we can say about the sky will always forever be an inductive inference. We can believe whatever, right? We can come up with any number of models, right? We can come up with an arbitrary number of freaking models that will fit any arbitrary data set. And you know what? We're still no closer to the truth. We just have a model that works. Great, fantastic. We can always fucking jerk off to that. But we're not going to know the truth because those things, sun, star, moon, planets, I know you think they're accessible, but I don't think they're accessible. Stars certainly not. Even within your paradigm, ain't no human being ever going to a fucking star and hanging out. Okay, so like that, you can never actually know. You can believe in whatever the fuck you want about them, right? The stars. Think about it. For all of human history, we've been telling stories about the stars. No one's ever going to know. No human being is ever going to fucking know. If whatever story that they heard through all human history, any individual, they grew up in Rome or they grew up in Greece or they grew up in China, whatever story they told that or at any period of time, they're never going to know if that story was true, even though they could believe it with all their fucking heart. And we could have all these fucking, predictions and models and fucking explanations or whatever. They're never going to actually know. It's never going to be able to be proven because they're never going to be able to go there and test their theory. You see what I'm saying? It will never be falsifiable. So I figured it as a waste of time. That's why I don't care. So I can do whatever. I don't care because I can never actually know. I've accepted. I know the idea is like the spirit of exploration, and we're human beings. We can discover everything. I don't believe that bullshit. That's a bullshit story. We can't know everything.
No, I think you're right. Like, models are useful in that they could extend beyond what is actually observable, right? So into the place where it's, it works. It's not necessarily falsifiable outside observation, but it does. If it does apply to observation, you have the great thing about models is that they are supposed to be a reflection of reality in some sense. There are things you can say about reality from models.
Hey, Dan, have you started with observing curvature?
Yes.
Really? All right. Let's start with that. All right.
Do you want to? I'm not interested.
Let's see this.
It's a bit of an old thing. I'm enjoying this conversation we're doing already. I don't think we need to.
You're doing the thing that always happens in flat Earth where you drag through the whole. I've done that conversation thousands of times. I'm not interested in that one.
Oh, you're into theoretical shit. Oh, okay.
It's important to point out that there is some sort of agreement here where we all agree, I think, that you can use deduction to get closer to the truth, right? Even if you're not going to say, oh, the Earth's a sphere, you can definitely discount what definitely can't be the case, right? With falsification, like any falsified claim, we can eliminate a possibility and get closer to the truth down that method. Now, obviously, what me and Fessler seem to be agreeing on is that when nothing is presented and nothing is falsified, that a flat Earth, I mean, basically will never move anywhere because you're not presenting anything for us. Like, even if you do inevitably become a glober because of all of this, all these presentations that you could give us, if we never even get a chance to look at them, then you're never going to get closer to the truth.
What are you talking about, dude?
Yeah, no shit. So let's start with observing curvature.
Well, what I'm saying, AI.
Dan doesn't want to talk about it.
What I'm saying, AI is that the whole point, the whole principle of science is that, yeah, okay, when you affirm something, you're trying to support something or confirm, it's all tentative. But one thing we can do pretty confidently, not completely, but is eliminate possibilities, specific possibilities. And flat earthers seem to not give us the opportunity to eliminate, or not flat earthers, people in this sphere don't give us the opportunity to eliminate their possibilities because they never present anything.
Well, dude, who cares? Why would you want to put forth possibilities that are conjecture to be eliminated on the fact that they're conjecture in the first instance? You don't need to eliminate them. You could dismiss them out of hand.
Well, I'm not asking for conjecture. I'm asking it would have to be supported, right?
This is the problem with this conversation.
Yeah, I did one. Yeah, go ahead, Flatsy.
Sorry, I just want to point this out, and then you can have it. So this is the problem with this discussion. It's like everyone is always expecting, like, what's next? Flat earthers are flat earthers, so what's next? See, that's not the way that the flat earthers are thinking. We don't take for granted the basics and fundamentals, so we go and master those because those are taken for granted and aren't mastered by the majority of people. So we're not looking for what's next. We're looking to hone our fundamentals, our axioms, our like logic, the principles of logic, the laws of nature, the scientific method. These things we've mastered.
Yeah, well, look, what I would say is if it is the case that the things you're examining seem to point in the direction of a flat Earth, and whenever you try to build on that, each time you're trying to build on it, it seems to always contradict reality or fall apart, then maybe what you're taking from those fundamentals is misunderstood, right? And then maybe it was never flat to begin with. You're in.
I mean, like when people make claims. I mean, like when people make claims about 17 pixels that are supposedly 17 trillion light years away, and then they say, "Oh, this is a water-bearing planet." You mean like that baloney?
I'm not here to defend any of that shit, but I don't know.
I wouldn't want to either.
I'm specifically talking about how you would go about narrowing down whether or not flat Earth is true or not, and it certainly isn't going to be by establishing if the globe is true or not.
It's establishing that the surface is not curved. It's establishing that the surface isn't curved. That's the entirety of the proposition. There's nothing more to it than that.
Well, AI, I've been here for about maybe a year and 2-3 months, right? So not as long as you guys, but I've heard basically all of the basic arguments, right, from black swan to water is level and so on. At this stage, right, I still find it all interesting and I like watching the debate. But at this stage, I know that there'll be nothing new that could possibly change my mind because those are the limits of the debate, right? And so. Why is it the case that lots of people can cycle through this conversation, hear the same thing, and not be persuaded by it? It's because they know. I mean, whatever you're imagining is a good reason for flat Earth isn't sufficient.
They get persuaded by shit Glover arguments. They listen. From what I've seen and people I've talked to, that first started they started trolling flat Earth. That's how they started. So they heard a bunch of shitty Glover arguments and the inability to form fucking logical statements and to have like. Literally zero fucking rational basis for the statements. And they're lying, which is also a factor. And they're actually having no evidence for the stories, which is also a factor. So, like, it's the Globers that make flat earthers. It's not us. We're not doing anything. We're just trying to teach people, how do you determine what truth is in the first place? As you've seen from the final proposition, these fuckers don't even know how to discover what is the truth.
I agree. I think Globers have... one thing I've discovered is that all of these science nerds, and I don't like science, I think science is for losers, I've said this many times, a lot of these science nerds don't know how to string a logical syllogism together or anything like that, right? Or even, if I asked them what a proposition was, they probably wouldn't even be able to tell me, right? That's true.
Well,
it certainly has made me realize that... It certainly has made me realize that maybe the boundary of who I consider intelligent is maybe a bit more... I don't know, like, I used to think scientists were all knowing, but now I know they're quite limited sort of in scope of how much they can tell me, right? They have their own sort of lane, let's say, right? Whereas I thought before when I was a kid, they were in every lane. You know, science could tell you everything, which I don't think is the case anymore. But their pursuit, the reason why there are people like even me who don't like science and other people who are interested in science and they come here every day to have the same conversation day in, day out, knowing they won't be convinced, is
because I think that they want to test whether or not their arguments are good, and so in that sense, at least they're moving towards that direction.
Not even close, dude. Not even close.
There's a bit of entertainment in it as well.
Let me tell you what I think it is.
Psychosis.
They want to feel comfortable that we are not proving it to them in the sense that they could say, I'm trying, but I'm still believing what I believe. It's essentially a coping mechanism because they don't like the idea that flat earthers are convinced that the earth is flat against their worldview. So just like butthurt atheists that show up to Christian things to be like, how dare you tell me that your God is God and I can't, this or that. It's like, it's all the same thing. They're just a bunch of copers, dude.
Well, I mean, I'll tell you what I've experienced on my side, right? You remember GF6 when that was the thing? Like, there was a whole, we saw a meme about the fact that we would be, discreet and, just not tell everyone what we're doing, but make it seem like we're doing something. All we would do is we would hear an argument from a flat earther, we would go back and we'd try to find a new way to argue against it, right? How could we argue against it in a way that they haven't heard before? And that was the fun for us, that was the fun of it, right? It wasn't so much like some sort of insecurity about whether or not you guys think the Earth's flat or not, right?
Look, you Glover's been doing that for years, man. Back in the day, like back in 2018, end of 2017, motherfuckers had a spreadsheet on a Google Sheets, and they would come into the other Discord, and they would do trial balloons, right? So they would come in with an argument, report back to all the idiots on Jump here in the server, be like, yeah, this is what they said about it. And they would come back the next day, another person on another stock account with a modified version of that. That's why we have every argument, because we've heard every argument and every iteration of fucking every argument and every change and little manipulation here and a change here and change a word there and then present it this way. We've heard it all. At least I have. And
I think
heard it all.
The majority, before you go on, the majority of their argumentation is fallacious non-contingents. In other words, even if they prove their point, it's completely irrelevant, but they're using fallacies to try to do it. So the majority of the globe arguments are presuppositional loops. They're not even good arguments at all. They're completely arguing from the assumption that the Earth is already known to be a globe.
We all agree that most globes can't string a logical sentence together, though. There's no problem with that. And that's part of the fun as well, right? But it's not... But I don't think it's anything to do with trying to convince you that the Earth isn't flat, because I personally don't think I have the ability to do that, no matter what I could say.
Before you go on, the majority of their argumentation is fallacious non-contingents. In other words, even if they prove their point, it's completely irrelevant, but they're using fallacies to try to do it. So the majority of the globe arguments are presuppositional loops. They're not even good arguments at all. They're completely arguing from the assumption that the Earth is already known to be a globe.
We all agree that most globes can't string a logical sentence together, though. There's no problem with that. And
which I have. And
I think...
The majority, before you go on, the majority of their argumentation is fallacious non-contingents. In other words, even if they prove their point, it's completely irrelevant, but they're using fallacies to try to do it. So the majority of the globe arguments are presuppositional loops. They're not even good arguments at all. They're completely arguing from the assumption that the Earth is already known to be a globe. They're not even good arguments at all. They're completely arguing from the assumption that the Earth is already known to be a globe.
We all agree that most globes can't string a logical sentence together. There's no problem with that. And that's part of the fun as well, right? But it's not... But I don't think it's anything to do with trying to convince you that the Earth isn't flat, because I personally don't think I have the ability to do that. No matter what I could say how smart I am, I don't think that's possible.
You got with the empirical evidence.
Yeah, empirically direct surface curvature measurements rather than excuses of why it's not to be found.
So I have a lane, right? And science and maths isn't my lane, but I do... so what I have heard is that people like Shoebill and Jesse have both different methods for showing the curvature, right? Measuring curvature. And
whatever, dude.
As far as I'm aware...
Jesse's path of light, dude.
Yeah, just give me a second, because I think this is going to... I know what you're going to say, and I think I'm going to anticipate it. The way that Jesse prepares his tools for that measurement seems to be the thing in contention. But what I've heard is that the way that Shoebill does it is too, but they seem to be doing exactly the opposite of each other, which would make at least one of them correct.
Well, they both could be wrong.
I was about to say they could both be incorrect.
Oh, we are.
Measurement that they're doing? I'm curious. I haven't heard of it.
I'd have to link you up with them. I don't know exactly how they do it.
Well, we do.
So they make these fundamental presuppositions about what the flat Earth should see and what a globe Earth should see, right? And they just make these presuppositions about, hey, man, everything should be at this elevation. If, my crosshair, my theodolite should be here if the Earth was flat, and there if the Earth was a globe. There's no basis for them saying that. Because we know from observation that things off in the distance, the further away it is, the more compressed it looks. This isn't like a theory, because you have things like flattening of the sun. So Sun is observed when it sets to flatten out. It distorts, right? So why is it flattening out? Why isn't it being picked up like they say with refraction? Hey, it's being picked up over the curve. Well, it's not getting picked up over the curve. It's being fucking smushed. Vertically smushed. But it's not just that. We have actually measurements of this, right? So we have long-distance observations. Mount Jacinto, where you can measure items or features on the mountain, and you can put it into GeoGebra and measure them out. And then you look at the features, and then you look at how they should be in proportion to each other. I'm counting the pixels, and it doesn't match a globe or a flat Earth. Or fucking the infrared photography we got, where you compare the vertical, so you can count, like you can, because there's features, you can say, okay, these two features, they're 2 miles apart. Oh, 2 miles apart, okay, that's freaking 100 pixels. So 100 pixels should be 2 miles high, right? That's how it should be. 100 pixels are horizontal, right? So this is 2 miles horizontal. This is 2 miles vertical. Open the center of the image, all that crap. And then we see that the vertical is 10% missing. Why is 10% missing? It isn't because of Earth curve, because you're not comparing it to like what you don't see. You're comparing it to what you do see, and then what you do see, if you count the pixels, is 10% smaller than what the pixels say it should be. So we know, and then you compare infrared to visible light, and then you go, okay, here's a photo they took of the same thing, same time, visible light, infrared light. One appears smushed, the other one doesn't. We know things appear smushed in the distance. So his conclusions, based upon a presupposition, which is known to be false.
I think because I'm about to mute up in a second, just want to say one last thing, which is whilst I can say globers, so most of the time, 99% of the time, can't string a logical sentence together. I do think the emphasis on the black swan, I think it is a trash argument. I think it doesn't even come halfway into persuading or being convincing or even doing what it's supposed to do.
Well, I mean, that's fine, but there's more than just one black swan. There's a shitload of them. I think the most irrefutable argument is reflections, really.
The whole point of the black swan was to get globers to say refraction, so they'd give up their geometric horizon.
It's funny that you say. I was just telling this dude that he didn't really understand the black swan. Like, refraction, that's a concession. That's admitting that fucking we're right. Like, literally, you're conceding the argument as soon as you say refraction. You concede it.
I mean, it would be conceding if like someone like me who's never said it otherwise, right? It would be more just like, that would be my response to it. But I understand the rhetorical device, right? If you're saying that it is designed for those people who do assert that the horizon is geometric and that there isn't any refraction every single time you look at the horizon, there is this distance, which is you could never see it further than this. This is the distance, right? And then in which case that would be a good use of the argument. But I don't think it doesn't debunk the globe. Like, the final conclusion doesn't really follow.
Well, you need to go on X, right, and look around, because I swear to God, 10 times a day, someone says ships go over the geometric horizon. Like, every day. Like, some of you guys are hip on the black swan, but the vast majority of globers have never heard of it. They still say ships go over the horizon. They still say the same stupid shit that's on, if you Google flat Earth debunk, ships go over the horizon. They still been spewing their shit out. They haven't stopped. So, like, you may know about it, and maybe the people in this server may know about it, the globe earthers, but the average normie has no freaking clue about any of that. If I say to them, they go, ships go over the horizon, I go, oh, so is the horizon geometric again? They're like, what? They don't even know. They never even heard the black swan.
And it's just an example of how the rhetoric of the paradigm that we're given today, that we're taught, and I mean, there are people that go against it and they're still believing in the globe Earth, but we still have a narrative of claims that aren't substantiated, that are being put out to the public as information.
Yeah, so I could talk to this dude. I could talk to you about the black swan or the geometric horizon or the horizon, whether it's refracted or not, or where it's supposed to be, and you know what it is. But like these dudes, I literally have to start from scratch every time. Oh, ships go over the horizon. This horizon is geometric or physical. I have to explain what that means. I have to explain that the horizon moves around. I have to explain that it can't be physical. Like, I literally have to start from scratch every single time I talk about it, because they have no idea about what the argument even is. They don't have that clue.
I wouldn't mind that. Like, I think that's fine. But I do take umbrage with one thing, and that's that when people do sometimes explain the black swan, they present it as if it's like, okay, this is all there is to it, right? And this is the debunk. And they wouldn't even, like, if I was going to have that debate, I would say, okay, now you've heard the black swan and you're confused. Now's the part where you talk about, right? And sort of, it would just seem dishonest if you know what the objection is, but you just never say it. You know what I mean? I don't know. That seems dishonest.
Well, also, like, they've tried to model. So Walter Bisman has the black swan, like the oil rigs, and he's tried to match to his model, and he's had to fudge his model, right? So what he does is he puts a fog in past the oil rigs because he has to use such a custom refraction that the water appears like it's a fucking waterfall. So if you take away the fog that he obscures that with, it's literally, there's water that's higher than the oil rigs, behind the oil rigs. CJ made a little graphic with somebody surfing down it. Dude, it's ridiculous. And the camera's tilted, and there's a bunch of other problems. And the rays in the ray tracer, they invert, right? So the image should actually be it's actually an upside down image of a fucking waterfall, right? This is to get it to even look like the way it looks like, right? They have to model a ray trace that is just absurd and non-physical. But nobody talks about that. They just say refraction, as if that explained anything. It doesn't mean anything. They can't even model refraction using essentially what Bisman, a lot of people use, Bisman's calculator. And there's a ray tracer part of it, and the ray tracer can't model it like no matter what you do. So you can create custom gradients.
It definitely doesn't predict anything.
And you still can't get it to work.
Yeah, and it definitely doesn't predict anything. It uses already existing observations.
Well, I mean, you can't even post. What I'm saying is, though, Betsy, is that you can't even post-dict it. Well, think about that. You can't even post-dict it with fucking refraction sliders.
Right. Yeah, because even when they try to replicate the observation in the model, it doesn't match it at all. It's so warped and disfigured.
And we're supposed to take refraction as a plausible answer? I mean, it's bad enough they're using like some freaking ray tracer, but like they can't even get that to work.
It's not based off of prediction either, so
No.
that should be an alarming factor for you to push on us, because we don't have to claim that.
And then there's other oil rig videos, right? So there's an oil rig video, it's taken at dusk, so the lights of the oil rig are on, and they're reflecting off the surface of the water. So how are you seeing the reflection off the surface of the water that's supposed to be on the other side of the curve? Now you could say, yeah, the water's refracted up so you can see the water because the water's a mirage. But what is the light reflecting off of? The light has to reflect off a real surface. It can't reflect off a refracted surface because the angle of incidence equals the angle of reflection. So how can it reflect off a real surface to your eye when the surface you see is an optical illusion of the surface and not the actual surface? So that angle can't exist. That means you're seeing actual water. You're not seeing the refracted image of water. Then there's the Bolivian self-flex and their reflections. Like no one can answer any of the reflection shit. There's no. I've never even heard a Glober even try.
What reflection stuff?
But
symmetrical reflections.
Sorry, go ahead.
Yeah. So you like if you have the Bolivian salt flats, the Salt Lake salt flats, when they fill with water, they make a mirror, right? And that reflection is perfectly symmetrical. I should say perfectly. Perfectly is probably the word I hate. Nobody should be using that word, but it's symmetrical. Symmetrical, but then you can't tell that it's not symmetrical. Well, if it's a curved surface,
if the Earth was curved, it would be bent.
Yes,
it would be compressed.
And you can calculate how much, like the rays would diverge, and when they would start diverging, like what distance, right? So I got the sky and the reflected image of the sky, right? And I can compare them.
Do you have a photo where, I've never heard of this one. I'd love to look into it. Is there a specific photo?
The Bolivian salt flat? There's tons of them, dude. If you just go on Google, if you type in Bolivian salt flats and click images, you'll get hundreds of images.
I mean, just thinking off the top of my head, I would need to know what the field of view was of the camera, because the narrower the field of view, the less curvature would be present in the shot.
No, I'm talking about with distance, right? So you're looking at the reflection of the sky in the water.
Okay.
Right, and you can go, hey, that's the reflection of the sky. There's the sky. There's a dividing line that makes them look like they're a mirror image of each other, and you can compare them. Compare if they're symmetrical, right? As if the clouds are bigger, distorted in the reflection versus in the sky, right? You just compare it. Hey, the clouds in the reflection look the same size and proportions as the ones in the sky, and they're identical proportions. So it should be like distortion should begin as something like should start to be visible according to the globe. You go by the angle resolution of the eye, which is 0.02, right? So with 220 feet, that's when the 0.02 limit is hit. So after that, that angle distance increases. The Bolivian sulfides are 30 miles. You can see 30 miles. So if you can see 30 miles, the difference in angle is like half a degree. So that means you have a cloud. The top of a cloud and the bottom of a cloud. Its rays hit your eye. Well, the reflection of that cloud will reflect off the water, and because the rays are going to diverge because of the curved surface, that difference will be like 1 degree from difference from what you, or half a degree at 30 miles from what you see in the sky. It should be easily visible. And the thing is, it gets worse with distance. So you would see an increasing distortion as it got further and further away because the surface is curving exponentially, and you have the, like I said, the angle of incidence equals the angle of reflection. So you're always, the angle of the ray hitting the surface is constantly changing. It's increasing and increasing and increasing. But we don't see any distortions like that. So this is like one of the things, and people say, oh, that's just the Bolivian salt flats, like that's some magical place. But you can like, try to find other images of like calm water, lakes, ocean, even ocean, a calm ocean in a bay in, I think it was Iceland, maybe it's Finland or something. But that has like a perfectly symmetrical reflection in the sky. It's like, these are other indicators, like refraction. Like an indicator of refraction is not happening is lack of dispersion, no chromatic aberration, none of those like things that should happen because refraction is wave-length dependent. You should be observing some of those optical effects as well, right? Especially the more refraction it is, the more dispersion there is. So if something's being super refracted, you should see, this dispersion effect. You see it in astronomy, but you don't see it terrestrially, which is like another, big question.
Yeah, and with your what you were talking about with reflective surfaces, you can go around any surface of your house and find the angle of incidence where you see the reflective properties of any surface, even asphalt. You can go out there and find a reflective surface on asphalt too at the angle of incidence. You have to get low to the ground.
That's called a Fresnel.
But just that everything has a reflective property at an angle of incidence. That is happening out there at the horizon as well.
Cool.
It's a critical angle. Anything, no matter how rough the surface is, there is an angle where it will be reflective. Now, that angle might be so exceedingly small you can't ever reach it, or you can't resolve it, but it will have an angle where the light reflects off it, even if the surface is rough.
Yeah, I would like to try to find, there's so many things that my mind went to in this moment. Like, first of all, like double checking if the claim is true, that it would be, at first blush, it seems true what you're saying, that a curved surface should compress the reflection. But so I'd have to think more about that. I'd have to think if the scales are such that it would be apparent. Then I'd have to find a photograph that I can trust that accurately reflects reality, because a lot of these people that take photos of things like the sky reflecting beautifully on they're photoshopping afterwards to I know. So I don't know. There's a lot of
also some videos of it, right? So there are some videos. There's a particularly good one on YouTube. I think it's called "The World's Largest Mirror," and a particular segment of that
Bolivian salt flats.
Yeah, so there's a particular segment of that where it's like at sunset. Right, so you got a pretty good. So they're like in a Jeep. They're like outside the Jeep, looking at the sunset. But you can see the sun and then the reflection of the sun. But because sometimes the sunset's got shitloads of colors, right, and kind of like some streaming clouds. Like, it's a very good image for like comparison, because there's a lot of features that are really easy. Like, you go, man, that is like literally like a perfect reflection. And it's from a video, so it isn't even from like a Photoshop photo. Now, of course, they can color correct a video and do a bunch of bullshit. But I don't. It doesn't seem like they did that. Though they might have. But I don't rule that out.
My thought, thinking out loud, though, is that the distortion would be so far away, given the scale of the Earth, that the distortion would only be apparent at the very near the horizon. And would that even be noticeable? Right. The vast majority of the reflection near you would certainly not be noticeable. So, like, the question is, like, how much is a reasonable angular distance from the horizon to even be able to perceive this distortion that you're looking for on the scale that we're claiming it? I'd have to do some math.
I mean, all I know is if you do the math right, if you go, okay, they say the globe is 24,000 miles in circumference, right? So 0.02 degrees of that circumference is like 220 feet.
Yeah. Wait, did somebody already do the math on this? Can you link me to?
No, I mean, no. I can just give you what's in my head. What I just gave you. That's it. So if you like to subdivide, it's like 69 miles per degree, right, or whatever, right? So you just subdivide that, to 1/100ths of a degree.
Wait, say that again. What is your assumption? What per degree? At the beginning?
It's like 69 miles per degree.
But wouldn't that be? That's not a constant, right? Per angular degree, like for every degree towards the horizon is going to have more and more miles towards it as you look into the distance.
No, what I'm talking about is like the difference in angle, right?
Uh-huh.
So the difference in angle between I have a spot and I have a spot 220 feet away, the difference in angle, like the normal to that surface, is going to be 0.02 degrees.
Right. But yeah, so that's not quite the angle I'm looking for. I'm looking for like the projected angle, like how much of how far from the horizon down into the reflection would the distortion be even apparent to the naked eye? You know, does that make sense?
Yeah. It makes sense to me.
Like, because if it's less than a degree, like if it's in like point something degrees,
I'm just thinking as an angular difference, right? That's the way I'm thinking of it. There's an angular difference. So one ray, so say both rays come in at the same angle, right? And one hits in one spot and one hits in a spot 220 feet away. Their reflection angle is going to have a difference of 0.02 degrees because the intersection angle is 0.02 degrees. So they have to have a reflection angle. There's going to be a difference. Now, something I've thought about, but I'm not sure. Does that get worse if like the source of the ray is like more parallel to the surface, right? Because you have it like that, like, I don't know how to describe it. I'm getting tired actually. So, you know what I mean? Like, there's a difference between the ray coming straight down versus coming from the side, right? So they come from the side of the sphere. Yeah, like, is that? I think there'd be more distortion, like if it's coming like tangent to the surface as opposed to kind of like at a 45-degree angle or something.
Maybe.
I just think it would be worse because of the surface area thing.
Yeah, all I'm saying is like for every pixel of the image from starting from the horizon, every pixel is going to closer to the horizon is going to encompass more miles, right, vertically.
Yeah, of course. Yeah.
Than the pixel below it. So obviously, like the pixels in the bottom half of the image are just going to be, you can't tell shit, like the 0.02 you said. Nobody, you're not going to be able to tell that in the bottom half. You're only going to be able to tell in the last few pixels next to the horizon. I mean, is that going to be enough?
Yeah, I was thinking you could probably tell. Well, because the angle. I mean, I think a normal human being could see like a tenth of a degree difference, and that wouldn't be that far away.
I mean, and also you have to deal with the fact of all of the horizon effects, right? With refraction and stuff, it's going to be distorting shit anyway, right there at the edge.
I mean, it's best. I would just look at the images and judge for yourself if that looks like a curved surface. I mean, really, that's. Well, I mean, yes, you can go in. You can probably model it or something in 3D, maybe.
I'm just trying to say, like, think this through with you because you said nobody's even attempted to, and I don't know. The more that I'm thinking about it, the more it's not even an issue.
Yeah, well, everyone said scale, right? So yeah, scale is an argument, but like, no one can actually quantify it. Like, what is the scale?
Yeah.
All I know is I can go by what the Earth is, right? And if we have a difference of within the resolvable angle at 220 feet, it seems logical to me that, say, 2,020 feet away. So now you're going to have 10 times that difference, right? At a spot, and that's not even a mile away. That's a quarter mile away. And you can see across this salt flat 30 fucking miles.
Yep. Well, I'll try to do some math and see what comes up.
So, Indio, AI wanted you to say something in the chat. He asked something to start a discussion. How is it possible the water in Half-Life 2 looks better than modern games?
Oh, yeah, I brought that shit up. They flipped the level or something. Fuck, dude.
It was because of they had to render the image twice because of the reflection.
Yeah, that's how they did mirrors in Doom as well.
Mirrors is that the main character is a female doing like all of this parkour stuff, right?
That's Mirror's Edge, but yeah, I just meant mirrors, like literal mirrors.
Mirror's Edge. I played that back in the day. I forgot what it was.
I think that's mirrors in Doom, in the Doom engine. I remember Build, like Duke Nukem had it. Like,
maybe I might be thinking of Duke Nukem, not Doom.
Thinking of what's his name's Build engine.
Yeah. Thanks for correcting me.
No worries. What's the
John Romero
made Build? That was really amazing when it came out.
Yeah.
Because he also had like an editor. They like the dev tools they used to make Duke Nukem were his. Like it was boxed with the game too. All those tools. Ken Silverman, was that it? I don't think his name.
I thought it was. Wasn't it Carmack?
One guy developed that all on his own. One guy.
I thought it was Carmack, but maybe I'm getting that mixed up too.
No. I'm talking about the Duke Nukem engine.
Oh, right.
That was John Romero.
Oh, that's right. Because he left. They were working together, and then they left. They split.
Yeah, and then he made Katana, which is fucking horrible. And I remember Duke Nukem. They used to call it Duke Nukem Never Because this fucking shit took 15 years to come out.
Right. It was vaporwave. Or it did come out.
I wasn't even gonna unmute, but I'm here to kick ass and chew gum, and I'm all out of gum.
Duke Nukem resembles Quake.
Yeah.
Remember that whole game?
The graphics engine's more akin to Doom than Quake, because it did not 3D models. The enemies were still sprites in essence, right?
I remember Quake, Quake 2, Quake 3, Quake 4.
Oh yeah.